to solve the inequality. The main mistake made on this problem was distributing the 6 into the inequality. You really don't want to do that. With this problem, what you want to do is you want to first get, I'm sorry, not inequality. You want to get the absolute value. You want to get the absolute value all by itself. So we distributed it into the absolute value. Don't do that. So when I'm trying to get the absolute value all by itself, the first thing I want to do is get rid of the debris, all the things that are not absolute value. And it's generally easier to do pluses and minuses before you do multiplications and divisions. So I'm going to add 8 to both sides, and I get 6 absolute value. 4x plus 2 is less than 42. Everybody good with that? Okay. And then I want to get rid of this 6. Again, I want to get this absolute value all by itself, so I can divide both sides by 6. And then I'm going to get absolute value 4x plus 2 is less than, thank you. That was always one of my hard ones, like 7 times 6, you know, like 8 times 7 too. That's one of my hard ones. Yeah, you too? Yeah, I don't know why that is. Okay, so, all right. So once I get to here, I'm going to have to set up 2 possible solutions, or 2 ways to find the solution. And one way is to go, well, 4x plus 2 has to be less than 7. That one's pretty clear. But then the mistake that people were making is that they were saying, well, 4x plus 2 has to be less than negative 7, and that's not true. Okay. If we have an absolute value in here, what we're saying is that we're saying 4x plus 2 has to be less than 7, or negative 4x plus 2 has to be less than 7, right? Because if whatever I have in here, if it's positive or negative, the absolute value is going to make it positive, and that's what has to be less than 7. Does that make sense? Okay, so then this is incorrect, and what is correct is to write negative parentheses 4x plus 2 is less than 7. Okay, so then now I just need to solve both sides. So I have 4x is less than 5, subtracting 2 from both sides. So x is less than 5/4. And then over on this side here, I'm going to distribute the negative sign into the parentheses. So I get negative 4x minus 2 is less than 7. I'm going to add 2 to both sides. I'm going to get negative 4x is less than 9. But now I'm going to divide by negative 4. And I get x on this side. And I get 9/4 on that side. But because I divided by the negative over here, I have to flip the inequality sign. Yeah, that's what I meant right there. Yeah, negative 4. Okay, so I got my answers here, and now I have to graph it. So I'm going to make a number line. 0, 1, 2, 3, 4, negative 1, 2, 3, 4, and it has to be less than 5/4. So 5/4 is like 1 1/4. So like right there, going that way. And it also has to be greater than a negative 9/4. That's a little bit less than 2, right? Less than negative 2. So that would be right here going that way. And so my solution isn't that. My solution is only where they overlap. So this represents my solution. I don't think I took points off if you had those two graphs, but I did write in that you need to have the actual solution graph. Does that make sense to everybody? We're okay with that? Okay, good. Okay. Then I need to put this in interval notation. And interval notation is really just like a number line. This was -9/4, and this over here was +5/4, and my solution is everything between those two. So I don't include -9/4, but I'm going all the way to +5/4, but I'm not including that. Yes, please.
So you don't write like the U and like the infinity thing because like you're not included?
That is correct. That's right, because going out here to negative infinity is not included in the solution. The only thing that's in the solution is everything between -9/4 and +5/4. Does that make sense? Are we pretty good with that? Okay, so with this problem, I have an and compound inequality. So and means it has to solve that, and it has to solve that. So again, I'm going to get my x all by itself, so I'm going to subtract 3 from both sides. I'm going to get -8 less than 4x, and if I divide both sides by 4, I get -2 is less than x, or I kind of like to have my x's on the other side, so I can just kind of flip the whole thing, and it's x is greater than -2. And then for this one over here, I'm going to subtract 3 from both sides, so I get 4x is less than or equal to, that would be 16. And if I divide both sides by 4, I get x is less than or equal to 4. So I have it greater than something over here and less than something over there. So I'm going to graph my solution. Number line, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Greater than -2, so like that, but less than or equal to 4. So here's 4. That's a closed-in dot because it's less than or equal to, and it goes that way. But again, it's an and, right? So it has to satisfy both pieces of this compound inequality. So my answer, let's put it in a different color, is going to be just from there to there. All this stuff over here and all that stuff over there, I should write it in so you can see. All that stuff over here and all this stuff over there is not part of the answer. Okay? So again, using interval notation, I'm just going to do this blue piece here. I'm going to go from -2 all the way to 4, and 4 is included and -2 is not. So that's the way your interval notation would look. Pretty good? Okay. So here we have an or compound inequality, which means either that one can be true or that one can be true. So I'm going to solve for this one here. I'm going to subtract 4 from both sides. I get 2x is less than, what is that, 3, right? Yeah, so x is less than 3/2. Or, see, if I subtract 5 from both sides, I get 3x is greater than 9. So x is greater than 3. Everybody still with me here? Okay. So I'll make my graph. 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this piece right here says x is less than 3/2. So that's 1.5, and I'm going that way as one part of my solution. and x is greater than 3, oh, I made a mistake. I filled in the dot. Shouldn't do that because the dot is not supposed to be filled in. Okay, because it's just greater than 3. So there's 3 like that. And since it's an OR inequality, it's going to be both, yeah. Why is it on the negative side? Yeah, because I messed up. Yeah, that's a legitimate reason. Let's see. Is that better? Yeah, okay. See, it was always like that. Yeah, yeah. Oh, of course, now it's on tape. So it's, you can prove that I'm lying, right? Okay, right. Yeah, my bad. All right. So, all right. So, because it includes both of these, right, my interval notation is going to be this piece here, which starts at negative infinity and goes all the way to positive 3/2. And I also start at 3, and I go all the way to positive infinity, and both of those are joined by a union. So that's the interval notation for that. Are we okay with that? Yes, please. Well, this is an interesting question. Okay, so and this comes up, right? Do I only write union when it's an OR? I write union when I have two solutions. So actually, let's talk about that in relationship to the next problem, which was using complete sentences to summarize the differences between AND compound inequalities and OR compound inequalities. Okay, so I had a couple of answers that were really excellent. So one person answered, the AND compound inequality is the intersection of the solution sets. The OR compound inequality is the union of solution sets. So I thought that was a pretty good answer. Another one said, and I like this one better actually. And compound inequalities must satisfy both statements, while OR compound inequalities only have to satisfy one of the statements. Okay? But so let's just say I had, now a lot of people referenced how the graphs look, right? And I wrote not necessarily, and I think I dinged about a half a point or something like that. So what if I had something that said X, you're coming through on the microphone, you know. Everybody can hear you. I hope what you're saying is okay. All right, X is less than 3, or X is less than 5. Now that looks like kind of a dumb problem, you know, for a math class, but when you're actually doing things practically, you might actually end up with that answer. So if I was to graph that, here's 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Well, X is less than 3, and X is also less than 5. So our solution to this is, since it's OR, it includes both of those, right? But really the solution to this is this like negative infinity to 5. I don't need anything. I don't need the union negative infinity to 3 because that's included in negative infinity to 5. You kind of see what I'm saying here? Yeah. So it's not necessarily that they're going to go in both directions, but sometimes they will. Are we okay with that? Okay. Then the last one was extra credit, and oh, I know. Let me just. So here is the average monthly rent right there, $2,400, and we want to write an absolute value inequality to show the relationship between the actual price so that it doesn't differ from the average by more than $300 per month. And I think the way we went over this is we said it's the absolute value of the actual minus the average is less than or equal to the amount that, to the difference between the two. So in this particular case, it would be the absolute value of x minus 2400 less than or equal to 300, or you could have written it the absolute value of 2400 minus x is less than or equal to 300. So the difference between the actual and the average is going to be less than $300. That means it can be $300 greater or $300 less. Pretty good with that? Yes, Mia. Just the equation. Yeah, that's all it was asking for, was just the equation.